Hello, Internet. I want to talk to you about counting. No, not that kind. No, not that kind either. I want to talk to you about the kind of counting that can easily fool you into believing something is obviously true when it's neither obvious nor true. Here's Lambda. Lambda just learned that his country has 1,000 cases of some deadly disease, let's say vampirism, each year. Being a little paranoid, he badgers his doctor to test him for it. The test has a 99.99% accuracy. A few days later, Lambda gets a positive test result. Should he be worried? What are the chances that he's sick? If you guess that Lambda actually has a less than 1 in 10 chance of being sick, congratulations. Wait, what? How can such a highly accurate test produce such vague results? Let's find out. What do we know? We know how many people usually get vampirism in Lambda's country, how many people live there otherwise, and how good the test is. But that's not what Lambda cares about. The question he really cares about is, am I infected? Or rather, what are the odds or the likelihood that I am infected? The answer to this comes down to counting very carefully. The procedure is this. We first gather everyone relevant to our question. Then we split them up repeatedly into groups based on all the information we have. Finally, we identify the group that we care about and check how many members it has, or is expected to have, and perhaps compare it to some other group that we care about. Remember, the odds of something happening is simply the ratio between the various ways in which it can happen and the ways in which it cannot. So here are the 100 million residents of Lambda's country. Just for comparison, the United States has a little over 3 times as many people. Of these, we know that usually 1,000 of them are infected at any given time. Now remember that our test has a 99.99% accuracy. If we applied our test on everyone, we expect the test to mess up once every 10,000 trials, more or less. It's important to remember that these failures occur randomly. The test doesn't care if you're sick or healthy when messing up. The results will look something like this. Amongst the 1,000 who are infected, the test would almost certainly identify every single one of them. It's a really good test after all. Amongst everyone remaining, the test would correctly identify the vast majority of them as healthy. Well, 99.99% of them. Unfortunately, the test will mistakenly declare 0.01% of healthy people, that's 10,000 of them, as infected. The question now is, if the test declared you as infected, how likely is it that you are infected?